going to talk about the blood vessels, and we have the commonly blood vessels. That's the arteries. We have the arterioles. We have the veins. We have the venules. Then we also have the capillaries. So we are going to start with the arteries and the arterioles. Arteries and arterioles have thicker walls than the veins and the venules because they are closer to the heart and receive blood that's surging at a far greater pressure. We find that the blood from the heart, and we know that the function of the heart is pumping blood. So when this blood is from the heart, it's moving at a very high pressure. So the blood vessels that are from the heart, they need to have thicker walls, and these thicker walls are there so as to deal with this high pressure of blood. So arteries have smaller lumen than veins, a characteristic that help maintain the pressure of blood moving through the system. If you compare the diameters of the arteries, then you compare it with the diameters of the veins, you find that the veins have a greater diameter than the arteries. This, if we take just from a typical example, a larger pipe and a smaller pipe, if we compare, then let's say water is passing through these two pipes. We find that the pipe with the narrow lumen, the water within it will be moving at a very high pressure compared to the pipe that has a large lumen or a large diameter. We find that the water will be moving at a very low pressure. So these diameters are just like they help with the maintenance of the pressure within these blood vessels. Large arteries and veins contain small blood vessels within their walls known as the vasa vasorum. A vasa vasorum literally means vessel of a vessel. These are blood vessels within the greater blood vessels. And the greater blood vessels here we are talking about are the arteries and the veins. For example, for the arteries we have the aorta, and if you come to the veins we have the vena cava. So the function of this vasa vasorum is that they provide critical extents within these large blood vessels. So here's a diagram of our blood vessel, and here the vasa vasorum is they are well labeled here. These are the vasa vasorum. So now let's talk about the veins and the venules. A venule is an extremely small vein. So we find that multiple venules join to form a vein. So we find that these extremely small veins, several extremely small veins come together to form a vein. The walls of the venules consist of endothelium. Here's the endothelium we're talking about. Here's the endothelium, nicely labeled. And then we are also told that a thin middle layer with a few muscle cells and elastic fiber. Here, here the smooth muscle and the elastic fibers we are talking about. Here they are. Then we are also told that plus an outer layer of connective tissue fibers that constitute a very thin tunica externa. So a vein is a blood vessel that conducts blood towards the heart. We find that veins carry deoxygenated blood from the tissues and they transport them towards the heart for the first it goes to the lungs for gaseous exchange, then it's being transported back to the heart for pumping back into the tissues and the organs. So we find that compared to arteries, veins are thin-walled with the large irregular lumen. So because they are low in pressures, the veins are very low in pressures. Large veins are commonly equipped with valves that promote the unidirectional flow of blood. A unidirectional flow of blood is the movement of blood in one direction. If the blood is going towards the heart, all the blood within that blood vessel is moving towards the heart. Not that some is going towards the heart, we find that then some is backflowing towards the capillaries. So That is made to happen by the presence of the valves within these large blood vessels, the veins. We also find that they prevent backflow, and this backflow is due to maybe gravity and the low blood pressures within the vein. When the blood pressures are low, we find that the blood might not be able to move steadily towards the heart. And we find that gravity also will hinder this blood flow towards the heart. So that's the function of the valves. The valves enable this to happen, so enable the blood to move smoothly towards the heart. So here is the diagram of our valve. This obviously is a vein. Valves are found in a vein. So this one is a valve. It promotes unidirectional flow of blood and also prevents backflow of blood. Then we are done with the arteries, we are done with the veins. Now let's talk about the capillaries. The capillary is a microscopic channel that supplies blood to the tissue. From the word microscopic, that tells us that we can see the capillaries with the naked eyes. So of supply of blood within a tissue is known as perfusion. Exchange of gases and other substances occur in the capillaries. We find that in the respiratory system, we find that exchange of gases takes place within the alveoli and the capillaries. So that's why you say here, exchange of gases and other substance occur in the capillaries between the blood and the surrounding cells and their tissue fluids. So capillaries are the primary site for oxygen. That one is well explained. And nutrient exchange. We find that for nutrient exchange, that deals with the GIT, that's the digestive system. So we find that capillaries are the primary site for oxygen and nutrient exchange. Flow through nutrient exchange. Flow through capillaries is also described as microcirculation. The word micro means small, tiny. So it's like a small circulation. And we find there are three types of capillaries. We have the continuous capillaries, then we have the fenestrated and the sinusoid capillaries. So the three major types of capillaries, they differ according to their degree of leakiness. Leakiness is the ability of the the fluid to penetrate through the blood vessels. That's the capillaries. So if we look at the continuous capillaries, we find that their endothelium is complete. It has no pores, it has no fenestration. If we check the endothelium, we find that it's complete. It's found in almost all vascularized tissues. Continuous non-fenestrated capillaries make up the blood-brain barrier, and they do not have gaps between the endothelial cell. They control movement of water, oxygen, and other essentials between the blood and the brain. Then we have the fenestrated capillaries. Uh, they have pores. These pores are known as the fenestrations. These make the capillary permeable to large molecules. Fenestrated capillaries are commonly in the small intestine, which is the primary site of nutrient absorption, and as well as the kidney, which is it helps in the filtering of the blood. So we find that these pores they act as a sieve. So we find that large molecules are not allowed to pass within this sieve. It's, for example, let's say maybe you are sieving your tea. You find that if it's tea leaves, we find that they won't pass through the pores of the they won't pass through the pores, and we find that the water will pass easily through the pores. That's the function of these fenestrations, and that's the reason as to why we find them in the kidneys, so that to aid with the blood filtration, and also in the small intestine, a site of nutrient absorption. Then we also have the sinusoid capillaries. These are the least common type of capillaries. Sinusoid capillaries are flattened and they have extensive intercellular gaps. These very large opening allow for the passage of the largest molecules. For example, we have the plasma protein. They also allow even the passage of cells. Let's say maybe, for example, white blood cells, they can easily penetrate within the sinusoid capillaries. So blood flow through sinusoid is very slow. The slow blood flow allows for more time for gaseous exchange, nutrient exchange, and exchange of waste products. Sinusoid are found in the liver, spleen, bone marrow, lymph nodes, and many endocrine glands, including the pituitary and the adrenal glands. So here the capillaries we are talking about. Here's the continuous capillaries. If you check its endothelium, it's complete. It has no fenestration compared to the fenestrated one. Here we find it has so many pores. Here are the pores. Those are the fenestration we are talking about. Then here's the sinusoid that we said has very large gaps. These are the large gaps we were talking about. These are the large gaps. So that's all I had for my today's presentation. If you found the video to be helpful, make sure you don't forget to like and subscribe to my channel. I upload my videos every day, so make sure you subscribe so that at least you'll be updated anytime I upload my videos. Thank you. Let's meet in my next video.